In this lesson and the coming series of videos, we're going to start dipping our toes into our second application, which is visual wake words. Visual wake words represents a common microcontroller vision use case where the goal is to identify whether a person or an object of interest is actually present in the image or not. As we did with keyword spotting, I'm going to start off by talking about the sensor. In this particular case, it's going to be the image sensor, which generates RGB channels of input data that will be feeding into our neural network. At this point, I'm going to make sure that we go deeper into neural network design. So far, we've been training on neural networks from scratch. In this particular module, I'm going to show you how we can shortcut that process in order to accelerate the training time by reusing some of the information that the network has pre-trained from a prior experience. That is called transfer learning, and that will be the first aspect that we learn. More on that later. We will also learn how to make more efficient convolutional neural networks, where we want to reduce the computation demand and also network size in terms of number of parameters. We will introduce depth-wise separable convolutional neural networks, and that's the second aspect that we'll learn in this application. Finally, just as we study the metrics for keyword spotting applications, we will learn new metrics relevant to image-based object detection. Now, let's understand what an application of visual wake words looks like. Here, you're looking at a smart device where the machine is actually waking up only when it recognizes the owner. Of course, here you don't see the owner standing in front of the camera, but that's the implicit assumption. Another example of this is where you have a smart device that's sitting outside your house. It's a smart doorbell. It recognizes when someone shows up at the door, or perhaps it does not recognize when someone shows up at the door, in which case it might send you an alert. Now, clearly, both of these examples that we're talking about here are about processing the information that's coming in. Now, these are applications you might already be familiar in a wired device capacity. What's interesting, of course, here is that we are talking about untethering the device, which has the remarkable potential for real-world deployments. Think about trying to deploy a TinyML device in an office, which is looking at the occupancies, right? If there is no one occupying the room, perhaps you want the system to turn off the lights. Now, that might seem like a very simple thing to do. Well, let me tell you why the TinyML version is different from the non-TinyML version, again, from a real-world perspective. In the real world, if you want to put a device in any particular building, you often have to get permits. You have to get electrical certifications, you have to get clearances that might to be able to actually drill a hole in there. And because the building is not yours, you're just a tenant in the building, right? So trying to install a new piece of equipment, and there's all these mechanics of the kind that come into play that actually cost a lot, which has got nothing to actually do with the technology or the use case that simply is, anyone in the room. That's where TinyML becomes extremely powerful from a practical standpoint, because I can take a small device like this and I can just stick it. So it's called a lick and stick kind of sensor. And then I can set it up to automatically communicate to a server on Wi-Fi and then turn off the lights. It's so much simpler, and that's why people are actually excited about TinyML, even though some of these applications are things you could typically do by tethering them to the wall. So let's go ahead. What's another interesting application? Smart glasses, as we've spoken about before, are remarkably powerful application for TinyML. For instance, here, perhaps the camera is actually picking up the tag of 30% off sale, and it triggers the lens to focus in on that image that's actually of interest to guide you there for effective retail shopping. You have all these remarkable sensing capabilities in the glasses, so that they can complement your vision by triggering actions from objects detected in the same field of view. Or perhaps you're using these glasses as you're navigating through a new city. Instead of having to look at your phone all the time, your smart glasses are detecting critical waypoints and automatically projecting the information into your lens. And these are remarkably powerful mechanisms that are going to transform the way we actually experience things around us. And TinyML is right at the forefront of those. And that's just a handful of exciting examples to come. And so we're going to learn about some of the challenges associated with trying to achieve this sort of future. And we're also going to try to discover some of the opportunities that we have around here, specifically around challenges. And as we did previously, we touched on the performance-related aspects with latency and bandwidth. We'll talk about model capabilities in terms of accuracy and personalization. And we'll talk about the criticality of the data itself. How do we keep it secure and private, as well as how do we deploy models so that they don't consume too much energy, right? This is a recurring theme because we want to make sure that it fits on the resource-constrained devices. All of the same things that we've touched upon in the keyword spotting example application. How are we going to focus on the aspects that are actually quite unique and relevant to this particular application? Finally, we are interested in how we can get this model to actually run on the device and what are the capabilities that we unlock if we do that. We're not going to deploy the device yet. We're going to try and shrink the model down using new techniques, and so that is ready to fit on your device once we get into part 3. We will go through the entire pipeline design. We'll focus on some of the interesting aspects around training the model with transfer learning and learning how to optimize it for deployment with new convolutional neural network structures. And so now let's go ahead and see what are the specific challenges that we see with this application.